Okay, you probably found yourself here if you've ended up putting together an IT program, you've got a ticketing system, you got a couple of folks working on inbound requests in your help desk, this kind of thing. You've got some policies and procedures and this sort of stuff. And so now you're at a point where you would describe it as steady state. In a CMMI model, you're somewhere in the middle, right? You're not at initial, but you're not all the way over here at optimizing. Now, at that point, you've got to start asking yourself some questions about how do you want to start optimizing? There's a couple of variables, a couple of metrics that the organization is going to start looking at. The most common ones are SLAs and SLOs around response time and overall resolution time. If you're starting to try to optimize those, the general thing that people do is they go through and they take a look and say, okay, I need to make that and that faster. Not a bad way to approach it. This is like gross capacity modeling. You say, which thing do I do the most that takes the longest? Okay, I'll work on that. Now, the key thing about doing this is you need to be metrics guided when you do it. One of the things that I will tell you is, and the history of all interrupt driven work is fraught with this truth. Everybody, when asked what's the worst thing they do, talks about the last thing that pissed them off. It's just that simple. So if you're going to decide which thing you're going to automate or which thing you're going to improve or which thing you're going to deflect, you don't want to count on the emotional, visceral reaction of your team. You want to do it based on metrics, right? What happens the most? What takes the longest? Somewhere in that range is what you're going to improve. Then how are you going to improve it, right? And this is where it gets really interesting because the initial idea is, oh, okay, I'll just make that work go away and then things will get better. Doesn't work that way. And the reason is because of the arcana of queuing theory, right? And so queuing theory can come across like eldritch lore. 5 or 6 people know it. W. Edwards Deming is sitting out there and we're under his stern and watchful gaze. But at the end of the day, what you want to be able to do is you want to be able to take a look at the resources you have and then understand, okay, I have 2 people working my help desk and a ticket comes in. Okay, one of those 2 people is going to start working it. That sounds awesome. Another ticket comes in, that second person is going to become busy. And then if a third ticket comes in, that ticket is going to wait. And it's going to wait for the shortest length of time between those 2 tickets. The issue is that what you're going to find if you really model this out is if you have a mixture of long and short tickets, so some things that take a long time and some things take a very short time, your SLO is actually going to be much harder to meet than if everything was the same size. That's a magic of variance and this sort of thing. The reason I'm bringing this up is because as we think about improving over time, building an actual model, so a little bit less than just rate times time equals distance, actually some sort of a simulation or a model becomes very helpful for optimizing and figuring out, oh, okay, what do I have to do to deal with these nonlinearities and these second order effects in queuing?